Hey everyone, welcome back to the channel. Have you ever wondered what sound really is? We hear it every second of every day, but beyond just noise, sound holds some incredible secrets. It can shatter glass, create beautiful patterns, and even break the laws of physics as we know them. Today, we're diving deep into the mysteries of sound, from the explosive power of a sonic boom to the mesmerizing art of cymatics. This isn't just about hearing. It's about seeing and feeling the hidden world of vibrations. So turn up your speakers or maybe put on your headphones for this one, and let's get started. What if I told you that you could see sound? Not just on a computer screen, but physically, right in front of your eyes? This is the mind-blowing world of cymatics. The term from the Greek word chyma, meaning wave, is the study of visible sound and vibration. Imagine a thin metal plate with a fine layer of sand sprinkled on top. Now, imagine we play a specific musical note through a speaker connected to that plate. What happens? The sand, as if by magic, begins to move and arrange itself into stunningly intricate geometric patterns. It's not magic though, it's physics. Each frequency causes the plate to vibrate in a unique way. Some parts of the plate, called nodes, remain still, while other parts, called antinodes, vibrate intensely. The sand naturally gets pushed away from the vibrating antinodes and settles into the calm, still nodal lines. As we change the frequency, playing a higher or lower note, the pattern instantly dissolves and reforms into a completely new, equally beautiful design. These patterns, known as Chladni figures, show us that sound has a hidden architecture. It's a direct visual representation of the invisible energy that surrounds us. This phenomenon isn't just a cool party trick. It's used in engineering and design to understand how vibrations affect different structures. It reveals a fundamental truth: sound is not just chaos. It is organized, structured, and has the power to create order. Now, let's talk about a concept you've probably heard of, but maybe don't fully understand: resonance. Have you ever seen a video of an opera singer shattering a wine glass with just their voice? That's resonance in action. Every object, from a tiny wine glass to a massive bridge, has a natural frequency, a specific rate at which it prefers to vibrate. Think of it like pushing someone on a swing. If you push at just the right moment in their swing matching their natural frequency, they'll go higher and higher with very little effort. If you push at the wrong time, you'll just mess up their rhythm and they won't go very high at all. That's exactly what the opera singer is doing. They are finding the natural resonant frequency of the wine glass and matching it with the pitch of their voice. As they hold that note, the sound waves they produce are like those perfectly timed pushes on the swing. Each wave adds a little more energy to the glass, causing it to vibrate more and more violently. The glass is literally shaking itself apart from the inside. Eventually, the vibrations become so intense that the molecular structure of the glass can no longer handle the stress, and it shatters. This principle of resonance is everywhere. It's why certain notes on a piano make the whole room seem to hum. And it's a critical factor engineers must consider when designing buildings and bridges to make sure they don't resonate with wind or traffic and shake themselves to pieces. So sound can be seen, and it can build up energy to destructive levels. But can it travel faster than, well, sound? This brings us to one of the most dramatic sonic phenomena, the sonic boom. First, we need to understand the sound barrier. It's not a physical wall, but a concept. When an object, like a jet, moves through the air, it creates sound waves that travel ahead of it at the speed of sound, which is about 767 miles per hour, or 1,234 kilometers per hour at sea level. As the jet gets faster and approaches this speed, the sound waves in front of it can't get out of the way fast enough. They start to compress and pile up, creating a wall of high-pressure air. Breaking the sound barrier is when the jet finally pushes through this compressed wall of air. The moment it does, all those piled-up sound waves are released at once in a single, massive shock wave. From the ground, we hear this shock wave as a thunderous boom. It's so powerful it can feel like an explosion and can even rattle windows. What's fascinating is that the pilot of the jet doesn't hear the boom because they are traveling ahead of it. To them, the moment they go supersonic is surprisingly quiet. The sonic boom isn't a one-time event that happens only when the barrier is broken. The jet actually drags the shockwave behind it for as long as it's traveling faster than sound. So if a supersonic jet flies over a city, people in different parts of the city will hear the boom at different times as the shockwave passes over them. Now, let's get even stranger. What if I told you sound could create light? This sounds like science fiction, but it's a real and deeply mysterious phenomenon called sonoluminescence. Here's how it works. Scientists take a container of water and use powerful sound waves, usually in the ultrasonic range, to create a tiny bubble. They then use those same sound waves to trap the bubble and cause it to expand and then collapse violently, over and over again, thousands of times per second. During the final moments of this collapse, something incredible happens. The bubble emits a tiny, brief flash of light. What's causing this? Honestly, science isn't 100% sure, which is what makes it so exciting. The leading theory is that as the bubble collapses, the gas and water vapor trapped inside are compressed so intensely and so rapidly that they are heated to unimaginable temperatures, tens of thousands of degrees hotter than the surface of the sun. At these extreme temperatures, the atoms are stripped of their electrons, forming a plasma that emits light. It's like creating a tiny star in a jar of water using only sound. This phenomenon pushes the boundaries of our understanding of physics, linking acoustics, fluid dynamics, and quantum mechanics. Researchers are still studying sonoluminescence, hoping it might unlock new secrets about the nature of energy and matter itself. Finally, let's explore how sound shapes our perception of the world through the Doppler effect. You experience this every time an ambulance or a police car with its siren blaring speeds past you. As the vehicle approaches, the pitch of the siren seems to get higher, and as it moves away, the pitch drops. The siren itself isn't changing its tune, so what's going on? It's all about the sound waves. As the ambulance moves towards you, it's essentially catching up to the sound waves it's producing. This squashes the waves together, shortening their wavelength and increasing their frequency. Our brain interprets this higher frequency as a higher pitch. Then, as the ambulance passes and moves away, it's outrunning its sound waves. This stretches the waves out, making their wavelength longer and their frequency lower. Our brain hears this lower frequency as a lower pitch. This shift in frequency due to the motion of the source or the observer is the Doppler effect. It doesn't just apply to sound. It applies to all waves, including light. Astronomers use the Doppler effect with light from distant stars to tell if they are moving towards us or away from us, which is how we discovered that the universe is expanding. So that everyday change in a siren's pitch is based on the same fundamental principle that helps us understand the vastness of the cosmos. From the visible patterns of cymatics and the shattering power of resonance, to the explosive boom of a supersonic jet and the star-like flashes of sonoluminescence, sound is so much more than what we hear. It is a fundamental force that shapes our world in ways both seen and unseen. From the microscopic to the cosmic, it's a field of endless mystery and discovery. Thank you so much for joining me on this sonic adventure today. If you found this as fascinating as I do, please hit that like button and be sure to subscribe and turn on notifications so you don't miss our next deep dive. What other scientific mysteries do you want to explore? Let me know in the comments below. Until next time, keep listening and stay curious.